Alright, so this is another e one. So this is more like the first example. So I've got 12e to the x times e raised to the 3x, which again, I'm going to do this one a little different than before. I'm going to let x be the u part. And I'm going to put 12 with the e to the. And the reason why, remember, when I take the antiderivative of e to the 3x, I'm going to divide by 3. Well, if I have the 12 there, I have a 12 to divide by 3, which means I'm not going to have a fraction. And so I'm going to make the 12 go with the e to the 3x dx. Now, if you'd left it the other way around, it'll still simplify fine. You'll just simplify fractions later. Alright, this just makes life a little easier. Alright, when we take the derivative, du over dx here, I'm left with 1. It's just nice when that happens. And then on this case, when I take the antiderivative of 12e to the 3x, I get 12e to the 3x divided by 3, which simplifies to 4e to the 3x. So again, that's the reason why I put the 12 there. You don't have to. It's just kind of looking ahead, it makes it a little easier that I don't have any fractions. Alright, then plug it in. So remember, my original expression is equal to u times v minus the integration of v times du, which, so I replaced those 3 parts, go in there. U I made simply x, v is 4e to the 3x, minus v 4e to the 3x, and dx is equal to du. Alright, so there is my function I have to take the second antiderivative of. 4e to, so I still left with a divide by 3, but there's my final answer. Alright, my antiderivative is equal to x times 4x, if you, just, again, 4x, if you want to rewrite that as 4x, but you can leave it. If you took the derivative of this, it would give you your original expression. I'm just going to find it and leave it there. We'll go ahead and do the next example. So these are the 2 types. If I'm going to ask you on the test, I'm going to ask you one of these 2 types, right, on the quiz. It's either going to be a natural log type or an exponential type. Same thing on the final exam. It'll be a natural log type or an exponential type. Alright, so the exponential, you let the x term be the u. In this case, it's the opposite. I'm going to let the natural log, because I can't take an antiderivative of natural log. Alright, so the natural log is the u part. And so that means the 8x dx is the dv part. 8x dx. Alright, so I take the derivative of this here, which is 1 over x. And so whenever it's the natural log case, you're going to have a 1 over x dx. Which is something you're going to have to remember. Here, I'm going to antiderivative of 8x dx, which is going to give me 8x squared divided by 2, so I get a 4x squared. Alright, and there's my v. Now I plug it in my formula, so again, u times v minus the integration of v du. Plug in those 3 pieces. U was the natural log of x. V was 4x squared. Antiderivative of 4x squared times, don't forget, 1 over x dx. It's really easy to forget the 1 over x, which, again, you have to simplify that before I take my integration. So it's actually 4x dx. I'm going to integrate. And actually, I'm going to rewrite this. 4x squared, natural log of x, minus the antiderivative of 4x squared is, 4x is 4x squared divided by 2 plus c. And so my answer is 4x squared, natural log of x, minus 2x squared plus c. And there's my final answer. I'm going to go ahead and just finish out the video with the last one. I believe this is the last problem. So I've got an x squared times the natural log of 5x. So this one's a little more complex. I didn't write them out, but u. Alright, so u is the natural log expression, which leaves the x squared dx, the dv part. So this one's going to be a little messier. I'm going to have a little more parts to it. The antiderivative is, remember, 1 over 5x times 5. Well, the 5's reduce. Leave me with 1 over x dx. Alright, so there's that. There's that. The antiderivative of x squared dx is x cubed divided by 3. And this is the messy part. X cubed divided by 3. Alright, then I plug it in my formula. uv minus v du. U was the natural log of 5x, so ln of 5x, times v, which was x cubed divided by 3, minus v x cubed divided by 3, times 1 over x dx. Again, don't forget the 1 over x, which I'm going to rewrite this. Alright, I'm actually going to rewrite this as well. I'm going to move that to the front. I'm going to make this 1/3 x cubed times the natural log of 5 minus the integration of 1/3 x to the second dx. Alright, now I take my integral one last time. My general antiderivative is 1/3 x cubed natural log of 5x minus 1/3 x cubed divided by 3 plus c, and then simplify that to 1/9. So I get 1/3 x cubed natural log of 5x minus 1/9 x cubed plus c. And a lot of times you will get fractions like that in these type of problems. All right, so just kind of practice it. Those are the two types you're going to get. So you're going to get either one with a natural log or an exponential. All right, so just make sure you look at those and practice them.